Hello, here's some info on the asteroid belt, which you've probably heard of. It's located between the orbits of Mars and Jupiter. And we've got loads and loads of objects which are orbiting around the sun, but they're not as big as the planets. In fact, I mean, they're quite small. The largest that we get up to is one dwarf planet, Ceres, which is actually this picture here. That's the largest asteroid in the asteroid belt, but most of the things are small, irregularly shaped objects. I mean, they're irregularly shaped. You tend to get spherical objects as they get bigger. If something's got enough mass, it can pull itself into a more uniform shape, and you're more likely to get something that is planet-looking, like Ceres here. But yeah, most of them irregularly shaped lumps of rock. And as I say, they're all orbiting around the sun in the same way as the planets are. They're just smaller, and there's lots of them. So let's look at the location then. So we've got the sun here right in the middle of this picture. We can see there's the Earth. So that's one astronomical unit out there from the sun to the Earth in terms of the distance. If you do another astronomical unit, we are in the asteroid belt. Now you do a third one, we're nearly out of the other side of the bulk of it. So we're looking at about 2 to 3.5 astronomical units for the majority of the asteroid belt. I mean, that's not all of it, but most of it. And you can see we've got other asteroids in the neighborhood here. It's not like this is where all of the asteroids are. You see we've got these Trojans over here, which are in the orbit of Jupiter. They're the same distance from the sun as Jupiter. We've got Greeks on the other side here. Sometimes these are all just called Trojans, I think, but you've got, these other asteroids. They're in the same orbit as Jupiter. You've got some which are ahead, which are usually the ones that are called the Greeks. Then you've got some which are behind, which are then referred to as the Trojans. You see, we've also got these other ones here in the evenly spaced around sort of 120-degree locations here. So these Hildas, which are some of them opposite Jupiter, and you can see from these locations the symmetry that they've got around Jupiter. Jupiter is the key factor here for the shape, the distribution of the asteroids, and the fact that the asteroid belt exists in the first place. When the solar system was forming, and you've got all of this matter, which is then condensing down into this disk, which is rotating around the sun. And the matter in this disk is then it's colliding, and you're getting these sticky collisions in the formation of the planets. So they're moving. There's enough movement around that they're hitting each other, but they're not moving so fast that they're just shattering on collision. They're hitting each other. They're staying together, and they're being able to form larger planets. Well, the presence of Jupiter, which, massive planet, way bigger than any of the other planets, and the gravitational perturbation from the existence of Jupiter is giving extra kinetic energy, and you're getting shattering collisions rather than sticky collisions. It's just stopping a planet from forming in this area. We've got this big gap here between the orbit of Mars and the orbit of Jupiter, and there could have been a planet in there, but Jupiter has perturbed things. And it's also, along with stopping a planet from forming, it's setting the location of the asteroids, a distribution of these asteroids around the sun. We can see these Trojans and these Greeks. You've got stable points inside the orbit of Jupiter where these asteroids can exist, and they're not getting pushed somewhere else. Similarly with these Hildas. And then even within the main asteroid belt itself, there are bands. There'll be certain parts, certain distances from the sun where you'll get very few asteroids, just because of the resonances as Jupiter's orbiting around. You get little pushes and pulls and such like in and out of orbits, depending on where Jupiter is, and it gets them into these sort of resonant orbits. So although you've got a fairly you can see we've got asteroids everywhere in the belt. There'll be higher concentrations at certain distances from the sun than there are at others. Right, so as I say, they're in a range of sizes, these asteroids. The largest Ceres you're getting on for about 1,000 kilometers diameter. That's large enough to be classed as a dwarf planet. And there was a flyby, I can't remember the name of the satellite now, but there was a satellite flyby in, must have been about 2015, something like that. Found that there is a lot of water, comparatively speaking, on Ceres. Both as mostly as ice, but there's some liquid water there at times, depending on where it is in the orbit and what direction everything's facing in. But yeah, with Ceres, along with the other big ones, you got Vesta, you got Pallas, you got Hygeia. Although I've heard this pronounced in so many different ways: Hygeia, Hygeia. But I think Hygeia, I think, is the way most people go for. But I could have got that wrong. Those four objects, with Ceres being the largest one, they account for about 60% of all of the mass in the asteroid belt. And although there are a lot of asteroids, I mean, they've detected well over 100,000 objects have been detected, tracked inside the asteroid belt. You're still looking at a total mass of only about 3% of the moon. So it's not an enormous amount of mass there, because a lot of it would have been jettisoned. These asteroids don't just stay there forever. I mean, most of the meteorites that have landed on Earth, I mean, it's over 99% of all of the meteorites that we find on Earth have come from the asteroid belt. So they hit each other, they get pushed out of orbit. In the early days when the solar system was forming, they would have been scattering around. So there's not an enormous amount of mass there, and more would have stayed there if Jupiter hadn't stopped the planet from forming. But this is covering a large volume of space as well. We've got this torus shape of asteroids going around the sun, and you might have over 100,000. Well, we do have over 100,000 objects there, but it is a large volume. So it's not like you're watching Star Wars or something where they're having to blow up stuff with lasers to try and get through the asteroid belt. There are big gaps. I mean, the average separation between objects is about 1 million kilometers. So it's not that hard to get satellites through. You think the number of satellites, the Voyager satellites, Pioneers, New Horizons, Cassini, all of these satellites that have gone through the asteroid belt in order to do flybys and orbits of the outer planets, is not that hard to get a satellite through, really. It's there's still a lot of objects, but they're not that densely packed. Right, in terms of the history of knowing that it's there, when was it first speculated that there was an asteroid belt? We're going back to the end of the 16th century, really. So we got Kepler. He was doing, as I've said in the video on Kepler, he took a lot of measurements and he did a lot of observations. He was a great observational astronomer, and he was looking at where the planets were, and he was suggesting that there should be another planet between Mars and Jupiter. Now, of course, he didn't know about Uranus or Neptune, but it got as far as Saturn. So there were 6 known planets. And said, well, it just seems to be quite a big gap considering everything else that we know. I mean, there was this dodgy law that they had as well of these the positions of all of the orbits seem to be following some kind of arithmetic sequence. Turns out this is just some kind of coincidence, it seems to be. But it was given quite a lot of credence at the time, and there seemed to be a planet missing for what would have been the 5th one in the sequence after Mars. So they started looking around anyway, but of course the telescopic equipment wasn't great back in 1600 and the early 17th century. But by the time we got to 1801, and you had Italian guy Giuseppe Piazzi, and he was at the University of Palermo, so that's down Sicily, southern Italy. And this is when he discovered Ceres. He spotted this thing moving around, and it was kind of weird. I mean, the following year as well, you had Heinrich Olbers. He discovered Pallas. So as 2 of the big 4 have been discovered in quick succession at the beginning of the 19th century. And they found it weird because they were unlike planets in that they remained as points of light even at high magnification under a telescope. If you're looking at them through the eyepiece, any of the other planets, you can resolve them into disks pretty easily. Even at that time, if you were looking at something like, well, Saturn, you'd see the rings. Jupiter, you'd see bands and the red spot. So there was a lot of detail that you could see, even with what nowadays would be considered fairly primitive telescopes. Yet with these asteroids, they just remained like star-like points, but they moved like planets. They moved quickly like planets, but they looked like faint stars. So hence the name, asteroid. Well, I don't need to write it out. It's written there. Asteroid, so sort of star-like. This was coined by William Herschel. Who had one of the really big telescopes named after him. Another great observational astronomer. So they were a little bit of a mystery as to what was going on. But of course, as the astronomical techniques improved and started seeing more and more of these objects, then the understanding of what exactly was going on here and how that could feed into our model of how the solar system was constructed, how it formed in the early days. It's invaluable information. So it's sort of pieced up over a few hundred years, really, the understanding of the asteroid belt. It's not the only place where we've got asteroids inside the solar system. I mean, the Kuiper belt is a particular. That's bigger than the asteroid belt. So the Kuiper belt, you're going further out. So you're going beyond Neptune, the last planet. So you're getting to 30 to 50 astronomical units away. It's 20 times wider than the asteroid belt. It's got maybe up to 200 times the mass. So you've got loads and loads of asteroids there. Different sort of composition for the asteroids. I mean, the ones that we've got in the asteroid belt here, they mainly fall into three classes of asteroids. You've got the ones that are very carbon rich. You've got silicon or oxygen rich, if I can say it, silicon or oxygen rich. So these are your silicates when you're combining silicon and oxygen. And then you've got some which are metal rich. So they might have a lot of iron or nickel, such like. When you get out to the Kuiper belt and you're that far away from the sun, you've got a lot more frozen stuff, a lot more water, ice, frozen ammonia, frozen methane, things like that. And then, this is all in the Kuiper belt. You've got Pluto is in that part of the solar system. So, now a dwarf planet rather than considered to be a planet. It's less understood what's going on in the Kuiper belt for obvious reasons. It's a long way away. You can't observe it as easily. It's it's a long way to get a satellite over there. I mean, even more so, you've then got beyond that, you've got the Oort cloud. So OORT, Oort cloud. This is to a large extent, this is a theorized part of the solar system because you're getting so far away now. Here we were, talking in the sort of 30 to 50 astronomical units for the Kuiper belt. So that's already 10 times or more the distance to the asteroid belt. Oort cloud, you might be looking at 2,000, even out to maybe 200,000. No one really knows astronomical units. It's theorized to contain billions of the long period comets. So the ones that we don't even know if they're ever going to come back. It's so long, centuries, millennia in between when they're going to be returning. Who knows what's going on with these comets. The short period comets are in the Kuiper belt. That's where they'll be coming from, and they do these highly elliptical orbits where they come in pretty close and then they're going highly elliptical back out to the Kuiper belt again. You think of how far they've got to get away from the sun to get back where they started. So they have interesting orbits, those comets. For the much longer period comets, then the Oort cloud is thought to be where they're coming from. But again, we know very little about that. I mean, how many objects, satellites? We don't get satellites to the Oort cloud. I mean, I know we think we've got things like Voyager of now, 1 and 2, and various others have left the solar system, but it's not a part of the universe that we're really observing in any particular way. So yeah, more information required about the Kuiper Belt and the Oort cloud, really. But yeah, the asteroid belt we know a relatively significant amount of stuff about, really. And it is a very interesting feature of the solar system, and it really shows the effect of having something as huge as Jupiter as a planet, and the effect that that can have on everything else, and the orbits and the position of all of these things, its existence in the first place. So yeah, fascinating part of the solar system.